the spirit.
Yeah, I don't understand so.
Oh, wonderful.
Just letting you know.
Can they come to extra help tomorrow?
It's tomorrow.
Thursdays, never mind.
Thursday. All right, so homeowner wants to enlarge a closet that has an area of x squared plus 3x plus 2 square feet. The length is x plus 2 feet. After construction, there will be an x squared plus 8x plus 15 square feet area with a length of x plus 3 feet. All right, so a lot of just information to set us up. But they seem to be talking about area a great deal, so let's just make a note. We're talking about a rectangular interval or region. So area would be equal to length times width. All right. So I have an area, because we're talking about before construction. So my area before construction was x squared plus 3x plus 2. That should be the product of some length and some width. All right. They give us the length as x plus 2. We need to figure out the width. All right. When they ask it like this, it seems like it would be harder to do, but it's actually easier to do because they're telling us what the product is, and then they're telling us what one of the factors are. They're not just flat out asking us to factor the polynomial. So all I would need to do is figure out what I'd have to multiply this by in order to get this. And it's even easier than you might think because that just means I got to figure out what'll make the x into an x squared if I multiply an x, and what would make the 2 into a 2 if I multiply a 1. So x plus 1 should be my other factor. All right. If you wanted to, you could ignore the x plus 2 and factor this original expression the way we've been working on last week. And then once you do that, you'll see that one of the factors is x plus 2. And then you can go from there. But this is even easier because they're just telling you one part of it. Now, if you were to check this, the outer terms multiply to 1x, the inner terms multiply to 2x, that'll give us a sum of 3x in the middle. Okay, so it's a quick, nifty way of checking to see that your factors actually make sense. All right. We should actually state our final answer because it says find the dimensions. So we should be pretty clear about that. Dim for dimensions if you want. Length first by width. So x plus 2 feet by x plus 1 foot or feet. You could write ft for feet if you want. You could actually just write out the word feet. Or you could just use that little prime symbol there. That works. All right, so we have to do the same thing, just now allowing for it to be after the construction rather than before. Just do it like this. Bless you.
Salud.
Them's fighting words. No, they're not. All right, so x squared plus 8x plus 15 is our area. They're telling us the length is x plus 2. X plus 3. I was looking at the wrong thing. All right, so I have to multiply x by something in order to get x squared. What am I multiplying by? X. I have to multiply 3 by something in order to get 15. 5, a positive 5. So now I have my factors, and I'll just state my answer the same way. All right, so x plus 3 feet by x plus 5 feet. All right, for part C, it's saying how many feet will the length and the width increase after construction. All right, well, we're assuming that all these x's are equivalent to one another. There's no reason to think that they're any different. So all we'd have to do is look for the difference between the constants. So 2 becomes 3, so the length increases by 1 foot, and 1 becomes 5, so the width increases by 4 feet. Right, because everything else remains the same. So it's an applied version of what we've been working on. It just doesn't really seem very real worldy. You know, the homeowner wants to enlarge a closet. I mean, I'm building a closet. I'm probably not writing a polynomial to represent the area. Get out the old tape measure. All right. That's what I want it to be there. That's what I want it to be there. We got an 8-foot ceiling. Simple multiplication. I don't think I'm solving for a particular. Yeah, even if somebody were to say, all right, you're tearing out the old closet and you're putting a new one in. Yeah, how big was the, how much more area did you get, or volume actually, because it's 3 dimensions. How much more space did you get by increasing the size? I'm still not setting up a polynomial. I'm still going to measure the difference in the length, the difference in the width, and the height should be the same, unless you change that. So I'm basically destroying the need to learn this particular concept, except to say that they tend to want to put stuff like this on the Regents exam, regardless of how nonsensical it might seem. Right? You'll get to a point where setting up equations and solving them will make perfect sense. It's just not going to involve areas of closets. All right. Rectangle has an area of x squared plus 6x plus 8. The length is x plus 4. Find the width of the rectangle. And the follow-up, I think the follow-up is actually more meaningful than the actual question itself. Could it be a square? Because that's actually going to lead us into a concept that we're going to cover down the line. So x squared plus 6x plus 8 would be equal to the length, which is x plus 4, by the width, which would be what? X plus 2. Boom. So then, again, length, x plus 4, width, x plus 2. Could this ever be a square? No, not a square. Because what would have to be true in order for it to be a square? All sides have to be the same. So the length and width have to be equal to each other. So length and width are not the same. And that's all you'd have to say there. All right, so it's a little bit more of a meaningful connection. Still not real world, but at least it'll kind of gear you towards what you'll be covering next year. Because in geometry, you're going to be proving that different shapes are equivalent in area, volume, things like that. But also, you're going to be working with some algebraic expressions to represent lengths of sides and things along those lines. Okay, so this is probably more valuable than the previous one. Right? The most valuable would be the last one, because for some reason, I don't know why, we are very concerned with things like borders around rectangles, like picture frames, walkways, things like that, in math class, to the point where you'll see a problem that involves a border around a geometric figure in pretty much every math class you ever take. It would make it seem like that is the main idea. That's the thing that you need to know coming out of college, high school, college, whatever. To the point where it's like, why do I learn about anything else? Because this border around a rectangle seems to be really important. You know, let's just learn about that. And then also the other one is where you have some kind of rectangle, and then you cut out the corners. And when you cut out the corners, you can fold up the little flaps here. You fold up those flaps, it makes a box. And I actually have one on the corkboard back there. I put it together myself. I cut out the corners, And I folded up the little flappy flaps here, and I have a little box. Yeah, it's really not very functional, but pretty cool box. And we'll learn how to find things like volumes and areas related to those sorts of things. Again, not really sure why, except to say that they make really good math problems. But I don't think, okay, I did it once with sheet metal. I actually,
Sheet metal?
I used tin snips and cut out the corners and made a metal box out of it. I did it exactly once for a particular reason, because I needed to line the inside of my, the air conditioners, like through the wall air conditioners, just basically a big metal box. And so I needed to line that with aluminum because it was overheating, so I needed something to diffuse the heat. So I actually used that concept to line the base of it, to kind of make a little tray on the inside. I did that once in my entire life. So like 25 math classes in college, plus everything I learned in high school, almost 20 years of teaching experience. And one of the concepts that I have to teach in every class, every single math class, every year, I used exactly once in my real life. All right, so obviously we've got to come up with something better, but baby steps. Anyway, here it's a matter of saying, well, what's my total area going to be? If I had a pool, the pool accounts for a certain area, or in this case, the fountain. I wanted to put a walkway around, and how much total area is it going to account for? Right? It actually might seem like a dumb question, but when you get into manufacturing, you have certain types of material that are going to be used, and so you have, like X number of square feet to work with. If some part of it is concrete, and you have to pay a certain rate for the concrete, and other parts of it are grass, and you pay a certain rate to sod your lawn, and then another part of it is the pool area where you have to account for the amount of water that you're putting in the pool. Each one of those individual areas amount for a different rate. So when you call a cement company and you ask them to come pour cement for you, they want to know things like what are the dimensions of the area that they're going to need to fill with cement. So in that regard, it makes sense. However, I still don't think you're setting up an equation, x plus this, x minus that. I still think it's a ruler or a measuring tape, but this ties a little bit closer to that. All right, find the length of the fountain. All right, they're telling us that the area, so I don't even need to look at the picture there. The area is x squared plus 12x plus 20. It's going to be equal to some length times the given width, which is x plus 2. Oh, I almost put it in the wrong place. Not that it matters, but consistency. All right. So what would my length be? X plus 10.
But then how do you control it?
If you were to actually distribute this out, the double distributing, the outer terms, when they multiply together, would give you 2x, plus 10x would give you the 12x.
Okay.
All right. I think this is good enough for part A. I don't think I have to write a separate statement saying length is equal to x plus 10. I think it's pretty obvious that I'm saying that the x plus 10 is the length. They're telling us that a 2-foot walkway is being built around the fountain, and we want to find the dimensions of the outside border. All right, so let's go to the pool, the fountain, but it looks like a pool. So. Telling us we're tacking on 2 feet all around.
There's no picture for us.
You don't have a picture?
Not really.
Oh, you got like a crappy version of the...
Yeah.
Well, a crappier version of what I have. Mine's not even that good. All right, so I'm tacking on 2 feet. I'm starting with x plus 2, then I'm increasing by 2, and then 2 more. What would my total width be here, or length in this case? X plus 6. So this whole shebang here is x plus 6. Now the other part would be the, well, oh, blue is not going to work for me. Let's see, something that might stand out, a little orange, perhaps. X plus 10 is the other dimension. Oh, it's barely visible. Still increasing by 2 in each direction. So x plus 2 becomes x plus 14. All right, so dimensions, the length used to be x plus 10, so now it's x plus 14. Feet by x plus 6 feet. So then they want the total area. And the only thing you got to be really careful about here is it says find the dimensions of the outside border of the walkway. All right, so sometimes they'll say things like find the area of just the border, find the area of just the water area, you know, so it could be tricky, but they're saying what is this side? This is an outside border, and what is this side? So the context of the problem has us focused on a particular thing. All right, now if I find the area using those two as my dimensions, I'll have the area contained within the borders. So everything, in this case. So we'd be looking at x squared plus, what, 20x plus 84? And the units there would be square feet. All right, it seems lame that I would do this, but I'll take off half a point if you don't include the units in the proper way. All right, so make sure they're there. All right, the little tick marks here, we call them primes. I mean, they're basically apostrophes, but you know, anything along those lines, that's sufficient. But when it comes to a squared quantity, you probably want to write it like this. But also, again, lame, you want to have parentheses around this, because that's telling us that this entire quantity will give me a single number, and that is what the square feet are going to apply to. If I don't put the parentheses there, a person who's like, you never know what the Regents' instructions are going to be in terms of grading. They may direct us to think in a certain way, and that would be to say, if the parentheses aren't there, it's because they're saying really it's only the 84 that's in square feet, and everything else they don't really know. All right, so put the parentheses around it to be absolutely clear to the grader that you know that this entire expression is the area. Anytime you're demonstrating that you know what they're talking about, that's going to play out in your favor very well. All right.